Good morning, friends. So let's continue our discussion about matching engine algorithm. In the previous video, we went with the very brute force approach and used a very nice data structure linked list to implement this. So let's revise this again. So this is our brute force approach for matching engine algorithm. So we first of all, because as we know that for buy and sell orders matching, we have to maintain a sort of for buy orders, we need the highest priced buy order to be having the highest priority. And similarly for the sell orders, we need to maintain a data structure which having the lowest price as the highest priority. So first of all, whenever a new order is arrived in point two, so what we were doing is that we were adding the order to buy or sell orders based on the side of the order. Side is whether it's a buy or a sell. And based on that, again, we have to sort this because whenever we are adding to our data structure, for example, say linked list, as we discussed in the last video, in that case, we have to sort it every time. For sorting, for buy orders, we have to do it in the descending price order, which means that the highest priced order is at the head. And similarly, for the sell orders data structure for linked list, we have to do the sorting in the ascending price order, which means that the lowest price order would be at the head of the linked list. And once we do the adding for the buy and sell orders to our data structures and then sorting it, we found that the sorting is n log n time complexity, which is not good. That's why the performance was not good. Only once we are adding to our data structures, only then we were trying to match the orders. So can we do something better here? So in the previous video, as we've seen that when we add the order to the order book, it means that we are adding it and then adding at the last, and after that we are sorting it. Add last is because we are using linked list. Even if I used without add last, I just use add. By default, it will always add to the end of the list, whether it's an array list or linked list, it doesn't matter. I just explicitly marked this as add last, but the default behavior is that it's always adding to the last. And this is an O(1) operation because we don't need to shift any element after adding. But this is the part for sorting, which is n log n, which is taking most of the performance impact and causing our linked list data structure not to be an optimal solution when we are adding it and sorting it. So can we do better here? We will discuss about new data structure later on, but let's try to optimize our algorithm and whether we can improve this implementation. So let's go back to our matching engine algorithm. So here is the optimized matching algorithm, which I have just discovered. So when a new order arrives, why don't we check whether the order can be matched or not? If there is already an opposite side order sitting in our data structures, for example, if I receive a buy order and it can be already matched with the opposite sell orders data structure, then why not just match it first? First match it, and whatever the quantity is not filled, only then we add it to the order book. So this is what is a better optimization, because better performance wise, because every time we are not adding it unless there are some unfilled order to be added, and then only once we add it, then we can sort it later on. The sorting is something which is taking most of the time complexity. So that's why we want to avoid it to the end until we are left with any unfilled order. So again, let's revise this. Suppose I have received a buy order. So immediately I will check whether this buy order, without adding it to our buy order data structure to the linked list. First of all, we will check that whether this buy order can be matched with the opposite side sell order. If it is matched, then it's all good. We create the matching, and then we just remove those sell orders which are matched from the sell side order data structure. And if all the buy order that we have received just now, it is all exhausted, which means that it's all filled, that we don't need to add this buy order to our data structure, which means we are going to avoid all the adding and sorting part. So this would be much more optimal than our previous algorithm. Similarly, if we receive a sell order, and then we'll try to immediately match it if it's possible, if it's possible to match it based on the conditions that we discussed. If it's able to match with the opposite side buy order, then we just totally fill it. Only if it's unfilled, only then we are going to add it to our order book. So this is a small optimization, but it's very good. And in case of like market orders, this can be an optimal design, because for market order, we don't care about the opposite price. Every time we try to like fill with whatever price is available on the opposite side. So in that case, we may completely avoid the unfilled orders, and we can completely avoid the fourth step here, because market order most of the time it will be almost filled with the with whatever price is available. And that's why once we can avoid this fourth step, it means that we are avoiding adding our unfilled order to the data structures and sorting it. Sorting again, it is going to take n log n. So based on this design of our optimized matching algorithm, where we are trying to mass order first before adding it to our order book. So this is the implementation. So again, I'm going to use the same linked list data structure for both buy orders and sell orders, and just an order cache to maintain whether the order ID has already been received, because we want every order to be having a unique ID which hasn't come before. If it has come before, we cannot add a new order on top of it. We can only amend or cancel it. Okay, so this is where our add order is part is done, in which once we receive a new order from the client. So first of all, we do just the preconditions that order should not be null and order cache should not be containing the key before. I mean, this order should be unique and always sent for the first time. So instead of adding it to the order book, these are the two steps that we just discussed. We try to match the order first. Only if after matching, if this order has got any unfilled quantity, I mean, if order.get quantity is greater than 0, but only then they're going to add order to the order book. As we know that if you want to add order to the order book, then we have to do the sorting part, and the sorting part is n log n. This is what we want to avoid. So again, for the matching orders, as we discussed in the previous video or previous video also, it's quite straightforward. It's based on price and time parity. So okay, so what we are going to do is that, suppose I have received a buy order. So again, for the buy order, if the order is satisfied, then we are for the opposite side, it should be the sell orders list. This sell orders is our linked list, which is already sorted. So here is our sell orders, and this is buy order. So here, whenever we want to match the orders, if the order is buy, current order side is buy, then the opposite side would be the sell orders linked list, and vice versa. If you are receiving a sell order, then the opposite order would be the buy orders list. So this is what we get the opposite orders, and then we know that what is the criteria for matching. For matching any order, we have to always check that the head of the orders data structure has got buy price greater than or equal to the sell price. For example, the example that we have been talking about. So this part is actually, let me actually create my epic pen here. So okay, so this is my all my buy order books. This is all buy side. Let me change it to pink for sell, and this is for my sell up till this point. As we can see that this cell is having the highest priority for the sell orders because the price is the least, 20.25, and similarly the other sell orders are having higher price than this one. So this is the best sell price that is available, and also for the time, if for the same price, this or the second order, this was received at 901, so it has got a better time priority. So always there's a price time priority. One with having the lower price for sell order would be having a higher priority, but if the price is same, the one which has arrived earlier would be having the higher priority. This is called price time priority. Similarly, for buy order, as we can see that the highest priced order is having the highest priority, and similarly, if for the two prices 20.15, which are lower than this, it is having a lower priority than the fifth order, this one, and but for the fourth order, it was arrived at 906, and the sixth order was arrived at 909. So that's why this fourth order ID is having the higher priority than the sixth order ID. So this is what the basics that we have discussed before. Okay, so here we can see that right now in our order book, the best that we have, the best order buy order is at 20.20, and the best sell order price is at 20.25. Now, definitely, I mean, because we cannot match this, because right now the buy price 20.20 is less than 20.25. So in our matching price criteria, we have seen that. So only if the buy price is greater than or equal to sell price, only then the matching is possible. So this is what it has been listed here. If a new order buy order arrives, for example, and if its price is greater than or equal to 20.25, only then the matching can happen. Okay, so based on this, this was just for the revision of the matching algorithm that we discussed in the previous video as well. I just wanted to revise it. So this is what we have implemented here. So suppose if I have received a buy order, just take an example. If you have received a buy order, let me remove this. If I received a buy order, then we got opposite orders as sell orders. And then we have to check whether the quantity is greater than 0 or not. Only then we can match it, right? And also the opposite order said that sell order should not be empty. Only then we can match it. And this is the price match condition. So it's price, and we are going to get the first part, because we know that at the head of the linked list, we have got a best price order. In the price match, as we have discussed, that if the order dot side is buy and order dot get price is greater than equal to, and the buy order price is greater than equal to the sell side price, only then we can match it. And similarly, or if we have got a sell order, then the sell order price should be less than or equal to the buy side order price. This is the price match condition, as we just discussed. Okay, so let's go back here. So these are the conditions, and it's a while loop because it will keep on matching until we completely exhaust the coming order. So this is the condition that I'm putting, that aggressive order, which is the new order which has been received, it is matching with the best sell order in the order. Then the opposite side should be the sell order. So this is the printf statement, which will indicate that whether it's a buy order or sell order. Okay. So once we get this, then the matching criteria again, as we discussed, that first of all we get the best. For example, for the buy order, we'll first of all get the best sell order on the opposite side order. This is what this condition will do. Now we have got the best sell order to fill our buy order, and for the fill quantity, we have to take the minimum of both. For example, if I've got 100 quantity of buy order and there is a 200 quantity of sell order as a best sell order available, to match it, we can only match 100, right? The minimum of buy order quantity and the sell order quantity, which is 100 in this case. This is what this condition does. Undo. So again, we are just printing it out that this is the match order, and then we have to deduct that amount. For example, for the buy order, I have to deduct 100 quantity, which will mark it as 0. And similarly, for the opposite side order, if it is sell order having a quantity of 200, then we remove that quantity of the fill quantity from that, which is 100. So now after filling, the sell order quantity will reduce from 200 to 100. And only we are going to remove the opposite order from our order book, which is at the head right now. We can remove it only when the quantity is 0, which means that it's totally filled. Then we don't need to keep it in our data structures and remove it. So again, let's go through a very dry example. Suppose I got a buy order of 100 and there's a sell order of say 200 quantity. Now we keep on having this matching algorithm, and then we found that the fill quantity is minimum of it, which is 100. So the buy order would be completely filled and the sell order would be reduced from 200 to 100. And this condition will not go because our sell order is still having a quantity of 100. So after this condition, only for one loop, our new order, which is the buy order of 100 quantity, is completely filled. Once this is completely filled, then we don't need to execute this step, which means that we don't need to add it to the order book in a buy order side, buy order linked list, and avoid the sorting part. This is what a small optimization is done, but it actually has a huge impact. And when we are implementing a market order, as we discussed, this is all about this condition. And so as our improved algorithm, whenever we receive a new order, we will try to match the order first. And if its order is not fully filled, only then we are going to add it to the order book. So this optimization done. And there are some other follow-up questions that to display the market data level, add a functionality for cancellation or amendment of the orders, which we'll discuss later on. But in this, we just optimize our basic steps for matching. So I also created this test case, the similar test cases as we did before. So I'll just go through it quickly. So here we are just going to use our order book using list, which is our first implementation using the linked list. And these are the test cases. For the test cases, I'm creating this order book, and then I'm actually mimicking the same type of data structure on the order sequence that I have created here. So let me show you once quickly. So I'm actually trying to replicate the scenario where we have got 3 buy orders at this particular time, quantity and price. And similarly, I have got 3 sell orders. And because the prices are not matching, that's why our order book would be looking like this. So this is what I have done in my test case. So I'm adding the cell of say 20.30 with 100 quantity and all. So 3 cell orders, same as that order book that I just showed. And similarly for the buy order. And I'll also added a delay so that it mimics that, one order has been received earlier, so that the price, buy orders of this, any type of order which has the same price, one which received earlier has got a higher priority based on the price priority. So after this method, we would be having order book, print book. We will be having the same data structure as we just discussed for 3 order. And then we are doing this test order matching when we are sending a buy order of say 250 at 20.35. Now, if I go back again to the same design, so if I receive a new buy order of say 20.35, which is higher than all this like price that we have at the sell side, 20.25, it's even higher than 20.30. It means that we had a potential match. After that, only the matching would be done. So after matching everything, so we expect that there would be at least, I think, let me check the total design once again. So, okay, so we have got 20.35 at 250 quantity, right? So what we expect is that we should be at least having 2 or 3 fills. Let me check again. So if I send a 250 order, so it means that 100 would be done, 100 would be all done at this price. So 100 quantity of that buy order would be filled. Then again, 100 quantity of the sell order will be also filled. So let me actually show this. So this would be completely filled of 100 quantity with that 100 buy order. Similarly, this would be again filled with that 100. So after these 2 fills for both cells, now the buy order that was this of 250 quantity, that would be left with only 50. So which means that for this third order, for 50 quantity, it would be only matched for 150. This would be only 150, okay, after this match. And our buy order would be completely exhausted. So I expect that after all these fills, these 2 fills and this third partial fill, we would be having a order book like this, in which, let me delete this. So yeah, as expected, it would be 150 left. 150 after this, reducing this 200 minus 50, and then okay, so this is what we expect after 250 order of 20.35. So let me run this test case quickly and then expect that our is correct. So let me click on the run button. So I just completed this test case. So as expected, that for the current order book, it is shown as exactly the same order book that we have just shown. And after I send a buy order of say 200 at 10. So okay, so I think it has run the amendment order first. Let me only run it for. Let me click it down. So I only want to test the order matching part because I haven't discussed about amendment and cancel. So let me just run for this part. And we expect that at the end, it will be showing the same order book as we expect. So again, now our test case has run. It has run successfully. We can see that this cell order having the quantity like this, and it's exactly matching with the one we discussed here. The cell order of 3, 1, and 2 here. It's showing the same order book as here, 20.3, 20.3 with all this quantity, and similarly for buy orders. And after that, when I run this, send a new order of say 250 at 20. So it will try to match it first. So we can see that the first match order was 100 at 20.25, which is this part. This part was completely done. So let me again show this. This was completely matched, as we have seen here. This was completely matched. After that, the next aggressive buy order with 100 quantity left was 20.30, which is again shown here. This was completely matched again. And at the end, this was because 200 is already exhausted for the buy order, only 50 was left. This 50 would be matched as a partial fill for this, which we can see here, 50 at 20.35. And after this, let me delete all this. After this, once we have this order book after matching, it should be sell order with 150 quantity, same as what we have shown here. 150 quantity is shown here, and this is the remaining order book. So this is working exactly as we expect. And here we have got further optimized it by just changing the sequence that whenever the order is received first, we should match it first. Only for the unfilled portion, we have to add it to our order book. Here in this case, because the whole buy order was immediately matched, it was all exhausted, there was no unfilled order. That's why we avoided this matching it, adding it to the order book and going to that sorting part, which has a time complexity of n log n. So this was all about this linked list data structure, very basic how we optimize our matching engine algorithm. In the next video, we will try to avoid this data structure and try to have an alternative data structure as priority queue, and then see that what are the performance gains that we're going to do. So see you all in the next video when we discuss about the priority queue implementation.